Hello, my dear student. Myself, Dr. Sumit De. You are watching my YouTube channel. So, I uploaded different types of videos based on apply engineering mathematics and for B.Sc and M.Sc mathematics. Okay, today I'll discuss one of the most important topic, that is application of Laplace transform. Okay, so application here mainly solve differential equation by using Laplace transform. So here I have considered two problem. Now try to understand what is the first try to understand what is the difference between these two question. So just you can check some conditions are given. So here y0 is equals to 0, y dash 0 is equals to -1, and here in next question I have considered y0 is equals to 0 and y dash 0 equals to 0. Okay, so the condition the maybe 0, maybe non-zero, different types. According to the condition you have to use it. Okay, now to solve this question, first I need to recapitulate some formulas so that you can understand clearly, because here derivative is there. So we should discuss the derivative formula. So this is the recapitulation part. L of y dash t is equals to s L of y t minus y0. Okay, L of y double dash t means double derivative of y, that is a square L of yt minus s y0 minus a y dash 0, and L of y triple dash t, that means third derivative of y with respect to t, is s cube L of yt minus s square y0 minus s y dash 0 minus y double dash 0. Clear? So now we can try to understand. It's very simple. If you have only one derivative, that you can start from the power 1 and then gradually 0, y s to the power 0. Just here you can see y double dash, the double derivative start from a square, then s, then 0. That means s to the power 0. Here a square, s to the power 1, s to the power 0. Same thing is here, third order derivative you have, that is s cube, a square, s and s to the power 0. Okay, so from here it is clear that is when derivative goes on, the power of s gradually goes down term by term. Another interesting part is there, that is the derivative goes high. So from here y0, then y dash 0, that is a double derivative, it should be 1, and here it is a y0 and then y dash 0 and y double dash 0. So these are the basic formula from derivative Laplace transform on derivative part. Okay, now I'm going to discuss both problems one by one. So here I have considered two problems. I'll solve both and try to understand. It's very simple. Now, so try to understand solution. So here solve by Laplace transform of this particular problem. So please write down the given differential equation is. The given differential equation is y double dash t plus 4 yt is equals to sin t. Okay, what about the condition you have? Y0 is equals to 0 and y dash 0 is equals to -1. These are the given conditions. Next you write down taking Laplace transform of taking Laplace transform on both side of 1, that is your 1, we get. So what you have, L of y double dash t plus L of 4 yt is equals to L of sin t. So already you know the formula, already have discussed, that is your s square L of yt minus s y0 minus y dash 0. Okay, so from here it is clear, this up to this level, this is coming for this only. Okay, now next from here you may write 4 L of yt is equals to, what is the L of sin t? Already you know, 1 by s square plus 1. Okay, now if you can, now so just you can check here y0 and y dash 0 you have. So these are the given information, these are the given condition you have to substitute here. So from here you may write s square L of yt minus s into 0 minus 1 plus 4 L of yt is equals to 1 by s square plus 1. Please check line by line. Okay, so here basically you have to substitute the value. You may write using given conditions. Please write down. Okay, please check. Is it clear? So first you write down the differential equation along with the given condition whatever you have. Next you write down taking Laplace transform on both sides, we get L of this, L of that and this. Now already you know, already have discussed the derivative formula. S square L of yt minus s y0 minus y dash 0 plus 4 L of yt is equals to 1 by sin t formula s square plus 1. Now you can see using the given condition you have to substitute the value. So y0 here in this problem it is given 0 and y dash 0 it is given minus 1. Okay, shall I move to the next slide? Okay, thank you. Now, so please check from the last slide you have it. So ultimately it is coming when you s square for class 4 you are taking common L of yt. So s square you have 4, you have L of yt is common, and please remember this common should be on the left side. S square 4 on the left side you should write. Okay, and then here it is coming plus 1, then it should be s square plus 1 minus 1. Is it clear? So minus, this part is cancelled and this part is plus. When you transform the right side it is coming minus 1. So from here you may write L of yt is equals to 1 of s square plus 1 into s square plus 4 minus 1 by s square plus 4. Clear? Next, is it clear to all of you? Okay, next you write down taking inverse Laplace transform on taking inverse Laplace transform on both side, we get. Okay, so please write down. So L inverse of L of yt is equals to L inverse of 1 by s square plus 1 and s square plus 4 minus L inverse of 1 by s square plus 4. Okay, so now from here it is coming only yt and already you know that both are the quadratic you have. It is very easy to separate. It's very simple. Next you write down 1 by s square plus 1 minus 1 by s square plus 4. What is your extra term is coming? S square plus 4 minus of this, that is 3 is coming. So 1 by 3 is the adjustment, minus L inverse of 1 by s square plus 4. Please check. Is it clear? It's very easy. If you have a same factor, just you subtract it, then you take simplification. That is, if you simplify, it is coming s square minus plus 4 minus of s square plus 1. So if you simplify, it's coming 3 extra. Are you getting a point? That means if you can write here s square plus 4 minus of s square plus 3. If you simplify, that part will cancel. That is 4 minus 1. 4 minus 1, that is your 3. That's why I have mentioned 3 and is the adjustment. Is it clear to all of you? I think it is clear. Okay. Very simple. Shall I move to the next slide? Okay. Now you have, so it is very simple. 1 by 3 L inverse of 1 by s square plus 1 minus 1 by 3 L inverse of 1 by s square plus 4 minus L inverse of 1 by s square plus 4. Okay, so from here you may write 1 by 3 L inverse of 1 by s square plus 1. So this part is same. So you may write 1 by 4 by 3 L inverse of 1 by s square plus 4. Clear? Because minus 1 by 3 minus 1, if you consider, that is coming minus 4 by 3. Now what is your value? So if it implies, so yt is equals to, so from here already you know 1 by 3, it is your sine t, and from here 4 by 3 it is coming sine 2t by 2. Ultimately it is coming yt is equals to 1 by 3 sine t minus 2 by 3 sine 2t. That is the answer. Please check. So here I have used the formula L inverse of 1 by s square plus a square is equals to sine at by a. So here it is 4, that means 2 square. So that's why I have mentioned sine 2t by 2. Okay. Is it clear to all of you? One very simple, just you have to go through line by line. Automatically you can understand everything. Okay. It's very simple. First step is all about the first you have to write down your differential equation with condition, then taking Laplace transform of both sides of the given differential equation. Okay, then write down your derivative formula, then substitute in given condition. Okay, L of yt should be on the left side and all rest of the parts should be on the right side. Then you consider taking inverse Laplace transform and find its solution. Okay, I think it is clear to everyone. Now come to the next slide. Now I'm going to solve the second problem. So this is the second problem. Okay, now try to understand solution. Same process. The given differential equation is, so please write down y double dash t plus y double dash t plus yt is equals to e to the power t, and from here you have y0 is equals to 0, y dash 0 is equals to 0. Okay, so suppose this is number 1. Now we write down taking Laplace transform on both side of 1 we get. So please write down L of y double dash t plus L of yt is equals to L of e to the power t. So from here already you know the derivative formula, s square L of yt minus s y0 minus y dash 0. Okay, so this is coming from only, this portion is coming from only this part. Okay, now L of yt and L of e to the power t is coming s minus 1. Now listen carefully. So first step, this one. Okay, now you substitute the given condition y0 is equals to 0, and that ultimately it is coming s square L of yt plus L of yt is equals to 1 by s minus 1 using given condition. Okay, using given, oh, okay, is it clear? Now try to understand the second. Clear to all of you? Here we have considered, because the given information y0 is equals to 0 and y dash 0 equals to 0. So this part will be 0, this part will be 0. So ultimately it is coming first and second. Okay, now come to the information. So again you have to take some common. So already have informed, it should be a square plus 1. It is coming L of yt is equals to 1 by s minus 1. So from here you may write L of yt is equals to 1 by s minus 1 s square plus 1. Okay, so please write down taking inverse Laplace transform we get. Okay, so please write down L inverse of L of yt is equals to L inverse of 1 by s minus 1 and s square plus 1. Okay, now it is coming, now so it is coming y of t is equals to L inverse of 1 by s minus 1 and s square plus 1. Okay, so you can solve, ultimately our objective to solve this, correct? So we can solve this expression with different way, by partial fraction or any other method, but I can give you another way out to solve this question very easily. Now try to understand. Very simple. Now, so here you may write L inverse of 1 by s minus 1 minus of s square plus 1. Okay, clear? Then whatever the expression you have, you make it reverse, that is s plus 1. Now take the simplification part. It is coming s square plus 1 minus of s square minus 1. So ultimately it is come s square cancel 1 1. It is 2 is coming 2. So that means it's balanced by 2. Is it clear to all of you? I repeat once again. It's very simple. Whatever the expression you have, linear, and this process is applicable for linear and quadratic. So first you write down your linear part minus blank and quadratic part. Whatever the expression you have s minus 1, it should be reverse of it, that is s plus 1. Now you simplify. If you take LCM, you have a formula s square plus 1 minus s square minus 1, b square minus b square. Okay, now 2 is coming extra. Now you balance it. So ultimately it is coming 1 by 2 L inverse of 1 by s minus 1 minus 1 by 2 L inverse of s plus 1 by s square plus 1. So ultimately it is coming 1 by 2 e to the power t minus 1 by 2 L inverse of s by s square plus 1 minus 1 by 2 L inverse of 1 by s square plus 1. Clear? You separate this. So ultimately it is coming yt is equals to 1 by 2 e to the power t minus 1 by 2. This is nothing but cos t. And here it is 1 by 2, 1 by square plus 1 it is coming. That's all. Okay. So I think it is, this calculation process is totally known to you. You please revise this portion again and again so that you can understand this. Okay, thank you everyone for watching my lecture video, and please do subscribe my channel. And if you feel you're getting some benefits from here, please share this information to all other friends also within your college, within your university or other. Okay, thank you. And just mathematics. Thank you very much.